In addition to flame tests, it's also possible to identify cations or the metal ions in an unknown salt using a range of tests, basically where you react it with sodium hydroxide, and depending on the colour and the complex conformed, then it will help to identify the cation. So I've measured out 2 milliliters of a range of different salt solutions, and I'm going to add sodium hydroxide to each one, and based on the reaction predict which salt it is. So the first one, now this is sodium chloride, and when I add sodium hydroxide, essentially there's no reaction. So anything that doesn't form any precipitate with sodium hydroxide can either be lithium, sodium, or potassium. To actually identify between the three and to work out its sodium, I'd have to do a flame test, and the flame color would be yellow for sodium. So the next one is copper, and when I add the sodium hydroxide, a blue precipitate is formed, and that positively identifies it as as copper, so I don't need to do anything further. The third one is copper, and when I add sodium hydroxide, there is a white precipitate. So if a white precipitate is formed with sodium hydroxide, you then have to add a bit more to see if it dissolves. So it's not dissolving, which means that it's a white precipitate that's insoluble in excess sodium hydroxide, and the cation could be magnesium, calcium, or barium. To identify, again, I'd have to use a flame test, so because it's calcium it would show a brick red flame. The next one is a lead salt, and when I add sodium hydroxide, you can start to get a white precipitate, but as I add more, the precipitate starts to disappear and it goes back to cloudy. So based on this, it could be a number of different salts, including aluminium, zinc, or lead. So to identify that it is lead, I'd have to do a flame test, and it would burn with a grey-white flame for lead. So the next one is the iron 2+. As soon as I add sodium hydroxide, a green sort of brown precipitate is formed, and that's positive for iron 2. I don't need to do anything further. Next one is iron 3, and when I add sodium hydroxide, a darker brown precipitate is formed. It's kind of a rusty redder brown, and again that identifies it as the iron 3+ cation. Next one is chromium, and when I add sodium hydroxide, you get a sort of grey-green precipitate. One after this is nickel. When I add sodium hydroxide, you get a sort of light green precipitate. Again, that confirms that it's definitely a nickel cation. Second last one is silver. So when I add sodium hydroxide, you sort of get this grey-brown colour, and that identifies it as a silver ion. And finally, to a manganese cation, when I add, I get a sort of creamy brown precipitate, and again that also confirms that it is indeed the manganese cation. So using sodium hydroxide you can identify a range of cations, but with a few of them you also have to back this up with a flame test to make sure that you know the cation.